Hmm?
Your sound. Are they all off like the sound?
Digital show ancient Egypt.
The show's viewers in the sun's immersive art space will take a fantastic journey through time and space to the era of the ancient Egyptian civilization. Modern technologies create the effect of complete immersion, and the visual components and lenses with its realism in the smallest details. From the first seconds of the immersive digital show, you'll be immersed in the mystical atmosphere of ancient Egypt. You will find out the fascinating history of the emergence of the ancient Egyptian civilization. You will learn how hieroglyphs appeared, and why each color had its own symbolism. The show's script, each of its plots, and each component have been developed with the involvement of
The show's getting ready to start soon,
You'll
folks.
see the ancient pyramids of
Thanks for
Egypt
stopping by. Tap that like button while you're here.
ancient Egyptian
We'd appreciate it.
pharaohs in the Valley of the Kings. The solar system is a planetary system that includes the central star, the sun, and all natural space objects in heliocentric orbits. It was formed by the gravitational compression of a gas and dust cloud approximately 4.5 billion years ago. Most of the mass of the solar system is in the sun, whose mass is 740 times greater than the total mass of the planets. The 4 planets closest to the sun are called the terrestrial planets: Mercury, Venus, Earth, and Mars. They consist mainly of silicates and metals. The 4 planets further from the sun are called the giant planets: Jupiter, Saturn, Uranus, and Neptune. They are much more massive than the terrestrial planets.
Not
The largest
Uranus.
giant planets in the solar system, Jupiter and Saturn, consist mainly of hydrogen and helium, and are therefore classified as gas giants. The smaller giant planets, Uranus and Neptune, in addition to hydrogen and helium, contain mostly water, methane, and ammonia. Such planets are classified as a separate class of ice giants. Jupiter, Saturn, Uranus, and Neptune are surrounded by rings of dust and other particles.
The sun is one of the stars in our galaxy called the Milky Way, and the only star in the solar system. Other objects of this system orbit around the sun: planets and their satellites, dwarf planets and their satellites, asteroids, meteoroids, comets, and space dust. The effective surface temperature of the sun is 5780 Kelvin. Therefore, the sun shines with almost white light, but the direct light of the sun near the surface of our planet acquires some yellow tint due to stronger scattering and absorption of the shortwave part of the spectrum by the Earth's atmosphere. When the sky is clear, together with the blue scattered light from the sky, sunlight again gives white illumination. The sun is composed of 73% hydrogen and 25% helium, as well as other elements with lesser concentrations. For humans, animals, and plants, sunlight is very important. In a large part of them, light causes a change in circadian rhythm. Thus, humans are affected by light with an intensity of more than 1,000 lux, and its color matters. In areas of the Earth that receive little sunlight on average per year, such as the tundra, low temperatures, a short season of plant growth, low biodiversity, and stunted vegetation are established. Radiation from the sun is the main source of energy on Earth. This energy can be used in various natural and artificial processes. For example, plants, using it through photosynthesis, synthesize organic compounds with the release of oxygen. Direct heating by sunlight or energy conversion by photovoltaic cells, can be used to produce electricity. The sun's ultraviolet radiation has antiseptic properties, allowing it to be used to disinfect water and various objects. It also causes tanning and has other biological effects, such as stimulating the production of vitamin D in the body. Exposure to the ultraviolet part of the solar spectrum is strongly attenuated by the ozone layer in the Earth's atmosphere, so the intensity of ultraviolet radiation at the Earth's surface varies greatly with latitude. The Sun is a magnetically active star and has a strong magnetic field. A solar eclipse is an astronomical phenomenon in which the moon completely or partially covers the sun for a period of time when viewed from a certain part of the Earth. Solar eclipses occur only at new moon, and because of the inclination of the moon's orbit to the ecliptic plane, they do not occur at every new moon, but only from 2 to 5 times a year when the moon is near the node of its orbit at new moon. Solar eclipses are divided into total, partial, annular, and hybrid. In a total eclipse, complete coverage of the sun by the moon can be observed anywhere on Earth, while in a partial eclipse, complete coverage is not observed anywhere. The Sun is the closest star to Earth. The Sun is about 26,000 light years away from the center of the Milky Way and revolves around it in a box orbit, making one revolution in 250 million years. Light from the Sun takes 8 minutes to reach the Earth. Solar radiation sustains life on Earth and determines the climate.
Mercury is the smallest planet in the solar system and is also the closest to the Sun. Mercury has no atmosphere and has no satellites. Mercury is similar in size and appearance to the Moon, and may have once been a satellite of Venus. The Mercurian daily routine is quite strange. 2 years will pass in one day. The Sun is 3 times larger than on Earth and can change suns and even move backwards during the day. Such a long day causes the surface to heat up, and at night, without heat and atmosphere, it gets terribly cold, but already at a depth of only 1 meter. This difference is not felt, and the temperature always remains constant. Because of its proximity to the Sun, the planet can only be observed at the horizon, either just before sunrise or just after sunset. For this reason, ancient astronomers for a long time mistook Mercury for 2 different celestial bodies, which were given different names. Also noteworthy is the almost perfect circular shape of the celestial body, since the difference between its equatorial and polar diameters does not exceed 1 kilometer. About 57% of the planet's volume is occupied by a massive metallic core with a radius of about 2,000 kilometers. The core is surrounded by a 400-kilometer layer of mantle consisting of molten silicon-based rocks. The mantle, in turn, is covered by a solid crust 15 to 37 kilometers thick. The surface of the planet is riddled with a huge number of craters. From the analysis with which it follows that for the last 8 billion years, the celestial body has not shown any noticeable geological activity. In 1974, when the Mariner 10 spacecraft reached the vicinity of the planet, it photographed 45% of the surface of the celestial body and measured its temperature and magnetic field. It also detected a highly rarefied atmosphere of helium and other gases. On August 3, 2004, another spacecraft, Messenger, left the Earth and took 11 years to reach its destination. Between 2011 and 2015, Messenger provided scientists with hundreds of thousands of photographs. Venus is the third brightest object in the Earth's sky, the Sun and Moon, and the second planet from the Sun. Venus was a prime target for early interplanetary exploration. Because Venus rotates very slowly on its axis, a day on Venus is longer than a year. Venus makes a complete revolution on its axis in about 243 days. Venus has a dense atmosphere made up of more than 96% carbon dioxide. The atmospheric pressure of the planet's surface is 92 times that of the Earth's surface, and is approximately equal to the pressure of water at a depth of 900 meters. The surface of the planet is completely obscured by clouds of sulfuric acid that are opaquing visible light. Venus is much like Earth. Its average radius is 6,052 kilometers, or 95% of Earth's, and it too has an atmosphere. In the center of Venus are located metallic cores, of which is about 25% of the total mass of the planet in 1978. The first maps of Venus were made by the Pioneer Venus 1 spacecraft. The Magellan spacecraft was sent to Venus, which was a large specialized radar, between 1990 and 1994. It transmitted images of 95% of the planet's surface to Earth, with a resolution of 120 meters. Venus is always at dusk, with acid rain, hurricanes, volcanic eruptions, and lightning. Mars is the fourth farthest from the Sun, and the seventh largest planet in the solar system, along with Mercury, Venus, and Earth. It belongs to the family of terrestrial planets. It is named in honor of Mars, the ancient Roman god of war, corresponding to the ancient Greek Ares. Mars has two natural satellites, Phobos and Deimos, which are relatively small and irregularly shaped. The mass of the planet is 7% of the mass of the Earth. In linear size, Mars is almost exactly half the size of Earth. Mars has a change of seasons similar to Earth's. A year on Mars lasts 687 days, or about 669 Martian summer days. A Martian year is almost twice as long as an Earth year, which means it takes twice as long to complete a full revolution around the Sun, because of the reddish hue of the surface given to it by the mineral dioxide. Mars is often called the red planet. Mars' atmosphere is highly rarefied, with the pressure at its surface about 160 times less than Earth's. The large amount of dust leads to dust storms, which have a noticeable effect on the temperature distribution in the atmosphere of Mars. The average temperature of Mars is approximately 210 C. Unlike Earth, the mass of the Martian atmosphere varies greatly throughout the year due to the notably freezing of polar caps containing carbon dioxide. In winter, 20 to 30% of the total atmosphere is frozen on the polar cap, which is composed of carbon dioxide. The spring melting of the polar caps causes a dramatic increase in atmospheric pressure and the movement of large masses of gas to the opposite hemisphere, one is with large amounts of dust from the surface, resulting in dust storms. Jupiter is the largest planet in the solar system, the fifth in distance from the Sun. Jupiter, like Saturn, is classified as a gas giant. Jupiter's mass is 2.5 times greater than the total mass of all the other planets in the solar system combined, and 317 times greater than the mass of Earth. A number of atmospheric phenomena on Jupiter, storms, lightning, auroras, are orders of magnitude larger than those on Earth. A notable formation in the atmosphere is the Great Red Spot, a giant storm known since the 17th century. Jupiter is studied using ground-based and orbital telescopes Since the 1970s, 8 NASA interplanetary spacecraft have been sent to the planet: Pioneers, Voyagers, Galileo, Juno, and others. Jupiter plays an important role protecting the Earth with its powerful gravitational field from bombardment by large celestial bodies. Jupiter is the most powerful radio source in the solar system. After the Sun, the chemical composition of the inner layers of Jupiter cannot be determined by modern observational methods, but the distribution of chemical elements in the outer layers of the atmosphere is known with relatively high accuracy. Since they have been directly studied by the Galileo lander since December 7, 1995, the two main components of Jupiter's atmosphere are molecular hydrogen and helium. The reddish variations in the color of Jupiter can be explained by the presence of compounds of phosphorus, sulfur, carbon, and, possibly, organic matter arising from electrical discharges in the atmosphere. Jupiter has at least 95 satellites, the 4 largest of which, Io, Europa, Ganymede, and Callisto.
Saturn is the 6th most distant planet from the Sun and the
My
second
favorite
largest
planet.
in the solar system after Jupiter. Saturn is classified as a gas giant planet. Saturn is mostly composed of hydrogen, with admixtures of helium and traces of water, methane, ammonia, and heavy elements. The inner region is a relatively small core of iron, nickel, and ice, covered by a thin layer of metallic hydrogen and a gaseous outer layer. Saturn possesses a conspicuous system of rings. The rings are not a solid, but are made up of billions of tiny particles of mostly ice particles in near-planetary orbit. There are 3 main rings and a 4th, thinner ring. Together they reflect more light than the disk of Saturn itself. Saturn's rings are very thin. At about 155,000 miles in diameter, they are less than 1 mile thick. Despite their impressive appearance, the amount of matter that makes up the rings is extremely small. If assembled into a monolith, its diameter would not exceed 65 miles. There are 146 currently known satellites orbiting the planet. Titan is the largest of these, as well as the second largest satellite in the solar system after Jupiter's satellite, Ganymede, which is larger than Mercury and has the only dense atmosphere and methane seas and lakes among the satellites of the planets in the solar system.
Uranus and Neptune are almost like twins, almost the same size, very close masses and rotation periods, very similar composition,
Again,
thin and weak
not
rings.
Uranus.
So, the core of Uranus and Neptune is a mixture of metal and stone, and not metallic, like on Earth, and not metallic hydrogen, like on Jupiter and Saturn. The blue color of both planets is explained, as is believed, by the presence of methane in the upper layer of the atmosphere, which absorbs red and reflects blue sunlight. But there are also differences between Uranus and Neptune. The main one is the direction of rotation. Unlike slightly tilted Neptune, Uranus rotates lying on its side. Its axis of rotation lies almost exactly in the plane of the orbit. Therefore, almost the entire planet experiences half a year of colder day and half a year of colder night. Half a year on Uranus is 42 years on Earth. Due to such youthful and gradual heating and cooling, the weather on Uranus is very poor. No storms, no hurricanes, not even multicolored stripes along the equator. Uranus is the coldest planet, colder even than Neptune, which is a third further from the Sun. The temperature on the surface of Uranus drops to 50 degrees Kelvin.
A black hole is a
region of space-time whose gravitational attraction is so great that even objects moving at the speed of light, including quanta of light itself, cannot leave it. The boundary of this region is called the event horizon. Up here, when a star dies and its core shrinks to a critically small size, a black hole is a celestial object so dense that no nearby matter or radiation can escape its gravitational field. You can visualize the horizon of a black hole as a sphere, and its diameter will be proportional to the mass of the black hole. Hence, the more mass that enters the black hole, the larger the black hole becomes. However, compared to stellar objects, black holes are small because their mass is compressed into a very small volume by the irresistible gravitational pressure.
Babe.
For example, a black hole in the massive planet Earth has a radius of only a few millimeters. This is 10 billion times smaller than the actual radius of the Earth. The best way to understand how black holes form is to relate their appearance to the collapse of stars. A star that is large enough forms a black hole after nuclear fusion has ceased because everything that can already be synthesized has been synthesized. When the pressure created by fusion stops, the matter starts to shrink toward its own center and becomes denser and denser. Eventually, it becomes so dense that nothing can overcome the gravitational influence of the star's surface. This is how black holes are born. At the center of our Milky Way galaxy is a supermassive black hole millions of times heavier than the Sun. Some black holes can spin at 1,000 times a second. All stars are born, live, and die during this process. They gradually cool down and shrink at the end of their lives. A star shrinks so much that it becomes a black hole, which begins to absorb energy.
The solar system appears to be a perfectly tuned mechanism when viewed at large. By contrast, there is a real realm of chaos between the orbits of Mars and Jupiter. This is where hundreds of thousands of small celestial objects whiz around space in all sorts of directions, occasionally crossing other objects' orbits. They sometimes get in each other's way and produce thousands of shards and bits on collision. Of course, we'll be talking about the main asteroid belt, one of the most changeable and mysterious areas of the solar system. Today, over 300,000 small celestial bodies found here have been given names and numerical designations. While slowly spiraling up, its tiny particles scatter sun rays and create a very faint white glow. This glow is referred to as zodiacal light. Most objects of the main belt group together to form the so-called asteroid families, populations of asteroids of similar makeup and of the same origin. The asteroid belt is also conventionally divided into two large areas, inner and outer belt. It's in the outer part of the main belt that the largest object in this area of the solar system is situated, Ceres. This celestial object used to be called a planet, then an asteroid, but eventually in 2006 it was given the status of a dwarf planet. It was possible to do so thanks to the fact that Ceres has a spherical shape unlike the absolute majority of the other objects in the belt. There are millions of objects in the main belt, from dwarf planets to tiny meteoroids the size of a cobblestone. However, distances between them measure thousands upon thousands or even millions of kilometers. That is why a spacecraft crossing the belt would be running an almost negligible risk of getting hit by any astronomical body. Small though they may be, asteroids are important both from a scientific and practical point of view. Some main belt objects are real treasure troves, dating back to the early stages of the solar system formation. Studying them will give us clear insights into processes of how planets and other celestial bodies form. And in the future, asteroids will make sources of materials for space exploration.
There is a giant cloud in space, hundreds of light years away from Earth, with some of its areas concealing dozens of yet unborn stars. Others are ripped apart by tremendous flashes. The space here is permeated by lethal ionizing radiation and threads of red-hot hydrogen, and fiery vortices that are capable of absorbing whole stellar systems. This is where stars are born, a stellar nursery which is closest to the Earth. What does it conceal from us? There are stellar nurseries richly scattered across the galaxy, with some of them comparatively modest in size. Others stretch for tens and even hundreds of light years. These are vast nebulae made up of interstellar gas and dust, being inexorably compressed by gravity forces. Most of these tremendous clouds are barely visible against the abyss of space, but some of them can be seen from the Earth with the naked eye. One of these structures is the Orion Nebula, located 1,344 light years away from the Earth. It is a little object in the so-called Sword of Orion, a clearly visible line produced by three relatively bright light sources. Due to its large size and comparative closeness to the Earth, the nebula has been attractive for scientists ever since the early days of astronomy. It is hardly surprising, therefore, that this great structure is one of the best studied space objects. It was the Hubble Orbital Space Telescope that beamed back first images of the Orion Nebula back in 1993, where the rich diversity of its colors can be appreciated. Most of the material was of a reddish or bluish-purple hue, while unusual bright green lines of some peripheral areas were revealed by spectral analysis. This phenomenon perplexed scientists for a long time, as the observed radiation did not demonstrate any chemical element known at the time. There was even a hypothesis that was put forward about there being a hypothetical element in helium, argued to be not present on our planet, but allegedly amply scattered across clouds and space. However, with the advancement of science, it turned out that the light was emitted by extremely rarefied and ionized oxygen. This discovery accounted not only for the bizarre illumination of many nebulae, including our Sun. There are currently not less than 3,000 stars discovered in the Orion Nebula to date, as well as giant clouds of interstellar gas and a great number of protostars. All this amazing diversity of space objects is concentrated in an area of around 23 light years in diameter, all of them continuously and elaborately interacting with each other. The overall mass of the material concentrated here is around 10,000 solar masses.
Earth is the third planet in the solar system by distance from the Sun. It is the densest, fifth in diameter and mass among all the planets in the solar system, and the largest among the terrestrial planets, which also include Mercury, Venus, and Mars. The only known planet in the universe inhabited by living organisms. Scientific evidence indicates that the Earth formed from a solar nebula about 4.5 billion years ago. Approximately 71% of the planet's surface is occupied by the world ocean. The rest of the surface is occupied by continents and islands. Liquid water, necessary for all known life forms, does not exist on the surface of any of the known planets and planetoids in the solar system except Earth. The atmosphere is the gaseous envelope surrounding planet Earth. It consists of nitrogen and oxygen, with trace amounts of water vapor, carbon dioxide, and other gases. The Earth was first photographed from space in 1959 by the Explorer 6 spacecraft. The first person to see the Earth from space was Yuri Gagarin in 1961. The Apollo 8 crew in 1968 was the first to observe the Earthrise from lunar orbit. Human culture has formed many ideas about the structure of the universe, such as the concept of a flat Earth, a geocentric world system, and the Gaia hypothesis, according to which the Earth is a single superorganism. The fall of large several thousand miles in diameter asteroids to the Earth poses a danger of its destruction, but all such bodies observed in the modern era are too small for this, and their fall is dangerous only for the biosphere when passing through the atmosphere. They are mostly destroyed and burned up, not posing a significant threat to the Earth.
Astronautics is the practice of sending spacecraft beyond Earth's atmosphere into outer space, as with aeronautics, the restrictions of mass, temperatures, and external forces require applications in space survive extreme conditions, high brain vacuum, the radiation bombardment of interplanetary space, and the magnetic parts of low Earth orbits. Space launch vehicles must withstand titanic forces, while satellites may experience huge variations in temperature and very fuels. Extreme constraints on mass force astronautical engineers to face the constant need to save maximum time in order to maximize the action period that reaches orbit. The beginning of space and the ending of the air proposed was 100 kilometers, what corresponds to 62 miles above the ground. NASA, the National Aeronautics and Space Administration, is an independent agency of the United States federal government responsible for the civil space program, aeronautics research, and space research. NASA has led most of American space exploration programs, including Project Mercury, Project Gemini, the 1968 to 1972 Apollo moon landing missions, the Spiral Space Station, and the Space Shuttle.
The Hubble Space Telescope is a space telescope that was launched into low Earth orbit in 1990 and remains in operation. It is one of the largest and most versatile, renowned as a vital research tool and as a public relations tool for astronomy. Hubble features a 4 meters mirror that corresponds 7 feet 10 in, and its 5 main instruments that serve in the ultraviolet, visible, and near-infrared regions of the electromagnetic spectrum. Hubble's orbit outside the distortion of Earth's atmosphere allows it to capture extremely high-resolution images with substantially lower background light than ground-based telescopes. It has recorded some of the most detailed visible light images, allowing a deep view into space. Many Hubble observations have led to breakthroughs in astrophysics, such as determining the rate of expansion of the universe. While Hubble helped to refine estimates of the age of the universe, it also upended theories about its future. The high-resolution spectra and images provided by the Hubble have been especially well-suited to establishing the prevalence of black holes in the center of nearby galaxies. The Hubble programs further established that the masses of the nuclear black holes and properties of the galaxies are closely related. A unique window on the universe enabled by Hubble are the images of small patches of sun that are the deepest ever obtained at optical wavelengths. The images reveal galaxies billions of light years away, thereby providing information about the early universe, and have accordingly generated a wealth of scientific papers. Over 15,000 papers based on Hubble data have been published in peer-reviewed journals, and countless more have appeared in conference proceedings. Future of space exploration. Reusable spacecraft were an entirely new engineering challenge, something only seen in novels and films like Star Trek and War of the Worlds. Space tourism is the next step in space exploration using reusable vehicles. SpaceX Company, founded by Elon Musk in 2002, is increasingly moving towards the goal of making space and space travel more accessible to ordinary people. SpaceX has developed Starship, a reusable spacecraft that will be able to carry up to 100 passengers on long-term missions to Mars. Jeff Bezos, the head of the American aerospace company Blue Origin, talks about creating space orbital colonies that will exist in the form of capsules flying close to Earth. Richard Branson, the head of Virgin Galactic, believes that space flights will soon be available to everyone. Virgin Galactic's first commercial mission, Galactic 01, was launched on June 29, 2023. Perhaps in the future, space flights will be as commonplace as flying on an airplane.
Except the Jetsons.
Definitely is.
Thank you for visiting the Cosmos Journey Show. Follow us on Facebook and Instagram to stay updated on our mission
I'm over the camera. Well, thanks for watching the live stream. We appreciate you. We will be back here again. It was fantastic. We have different shows. There's a Bible story. We'll put a short out as well soon.
Yeah.
But yeah, definitely gotta come here. Not expensive.
So much fun.
Appreciate you for stopping by. If you're watching the replay, go ahead and tap that like button. Feel free to subscribe. Once again, thanks for stopping by. We appreciate you so much. And we're gonna go ahead and sign off. Thank you very much.
I think you're on to something. Because me and him were kind of talking about like the podcast and stuff.